So hi, welcome to lecture series on programming and data structure or data structures. So in the previous lectures, we have discussed about stack ADT. Hope you are clear with the principle behind the stack data structure. So today, let us discuss about the queue data structure. So as I said before, stack follows the principle last in first out. So now let us discuss about queue. So let us discuss this with the help of an example. Uh, assume multiple customers are in need of a single resource, making use of queue as a data structure. Example, you would have studied disk scheduling, CPU scheduling in case of operating system. So this overcomes the problem of insertion and deletion of elements. So Q is considered as an ordered collection of homogeneous elements, and it is a non-primitive data structure as we have discussed earlier. So there are two ends of the queue, the front end and the rear end. So if you want to add a new element, obviously new element will be added to the rear end. Assume you are standing in a queue for getting the ticket in the ticket counter. So if there is new person who wants to who wants to get the ticket, he will add to the queue at the end, at the last, or at the rear end. So if you want to insert a new element, this new element will be added from the rear end. So if you want to delete an element, that element will be removed from the front end. So this follows the mechanism, or this follows the principle first in, first out. So these two are the main operations in case of queue, which is different from stack data structure. One is NQ, other one is DQ. NQ is used for inserting an element, how push operation is used for inserting an element into the queue, into the stack. So in case of queue, NQ operation is used for inserting the element at the rear end, and DQ is used for deleting an element from the front end. In case of stack, pop operation is used for removing or deleting an element from the stack. So this is a routine for NQ operation. So if I want to insert an element into the queue, again in case of array implementation, if the queue is full, can I implement the NQ operation? Answer is no. So how to check if the queue is full or not? So since I have mentioned it is an array implementation, so how do we determine the size of the array? If it is, how do we check if it is full or not? If that last index is equal to, so what is the last index in an array? It is obviously size minus 1. So if the rear end, so this rear end is pointing to the last index, it's last filled index, correct? So if this rear end is equal to maximum size minus 1, it means the queue is full or the queue is overflowed. So in this case, you cannot insert an element. So if this condition is false, it means queue is not full. So still there is some space left to add an element. So I can insert an element into the queue. So for performing the DQ operation, what I should check? If we want to remove an element from the queue, obviously the queue has something, should have something. So if the queue is empty, I cannot remove an element from the front end. So here for checking if the queue is empty or not, what I should check? If the front is equal to rear, right? So if there are no elements in the queue, the front and rear will point to the same index. So if front is equal to rear, it means queue is empty. So at this case, I cannot perform DQ operation. Else I can remove the element from the front. So these are the various applications of the queue. So as we have discussed earlier, queue is also used in disk scheduling. It is used in CPU scheduling. It is also used in round robin scheduling and job scheduling. So whatever the scheduling problems may be. So if there are any scheduling related problems, without any doubt, you can use queue data structure for you can apply queue data structure for solving the scheduling related problems. So it is also used in keyboard button buffer. So the best example to understand the queue concept is printer. So if I'm giving more than one documents to print, which one will be printed first? The document that enters the queue first, the document that enters the print queue first will be printed first, correct? So the printing queue or the printer queue is the best example to understand queue data structure. So here are the few of the assessment questions on queue data structure. So what principle does queue follows? It follows first in, first out principle. So last in, first out, or first in, last out principle is followed by stack data structure. So assume if there are elements A, B, C, D which are placed in the queue and deleted one at a time, in what order will they be deleted? So first element to be inserted into the queue is A, and second element that is inserted as B, third element that is inserted as C, and fourth element that is inserted as D. So in queue, the elements are deleted in the order in which they are inserted, which is a reciprocal of stack data structure. So in queue, the order in which elements get inserted will be deleted in the same order. So obviously the order in which elements are removed are A, B, C, and D. But a stack data structure, the elements would have been removed in the order D, C, B, and D. So hope you understood the difference between these two, I suppose. So with this, we will wind up the queue data structures. So let me give a quick recap of what queue data structure is about. It follows the principle first in, first out. And here the insert operation is called NQ and the delete operation is called as DQ. So hope you understood queue data structure. In the next session, we will meet with some other interesting topic. So keep on watching and thanks for watching today's session. Thank you.